Hello there and welcome to velocity time graphs. Let's get straight into it. So what a velocity time graph does is it records your speed as you travel over a certain period of time. So let's just imagine then we're on our way on holiday and we're on the motorway and we're chugging along at 70 miles per hour. That's what the graph is recording here. It's recording that your speed was constantly at 70 miles per hour for the first 1 hour. Then a little bit of traffic builds up, and over the next quarter of an hour you have to slow down to 50 miles per hour. Then they have one of those speed control signs and you have to then travel at exactly 50 miles per hour for the next 45 minutes. But then steadily over the next half an hour your speed slowly reduces till you're at a complete standstill, chock-a-block full of traffic, and for the next half an hour you can't move at all. Your speed is 0. So that's what a velocity time graph measures. It measures the speed that you've been travelling at over a certain period of time. A velocity time graph is a graph that records your velocity over time. And what you see is that the flat lines exist where the velocity does not change, for example 70 miles per hour or 50 miles per hour or 0 miles per hour. Increasing lines, don't have any here, but increasing lines exist where the velocity is increasing. But we do have some decreasing lines here, this section here and this section here, where we have our velocity decreasing over time. We call that deceleration. So let's go through a few questions then where we're calculating the acceleration. So the acceleration can be calculated by the gradient of this graph. Gradient, remember, is difference in y divided by difference in x. So in this case, acceleration is the change in the velocity, that's the y-axis, divided by the change in time, that's the change in the x-axis. So let's use that little formula then to work out the gradient for this section of the graph here. In this section of the graph, we're going from 2 meters per second at time 2 seconds to this point here, which is 5 meters per second at 4 seconds. So we'll do a little gradient triangle and we'll calculate the acceleration here as the change in the velocity. So that is the change from 2 up to 5, that was a change of 3, over the course of 2 seconds from time 2 to time 4, so that's 2 seconds, so that would be 1.5, and then we've got to record the units. That's going to be meters per second squared. It's basically a change of 1.5 meters per second, so that's why it's meters per second squared. Now in the second section here, we'll work out the acceleration for part A, B, C, part D here. That has a change in time of 3 seconds and a change in speed of 5 meters per second. So 5 meters per second divided by 3 seconds, and that's going to be 1.67 meters per second squared. So that's how we calculate acceleration. It's just difference in y divided by difference in x. Very similar for the speed calculations on a distance time graph. But what about when we have decreasing lines, just as we had in that original graph? This is the original graph. In this case, it's still going to be the same formula. Change in velocity divided by change in time. So it's going to be a change in the velocity, which is from 70 to 50. So that acceleration there is going to be minus 20. In this case, we're going down from 70 to 50, so that's a change of negative 20. Over a change of 15 minutes. Now we don't use 15 minutes, we use a quarter of an hour. So divided by 0.25. So that's going to be minus 80 miles per hour squared. So that's a different way of writing miles per hour, but it's the hour bit that's being squared. So this is decelerating at 80 miles per hour squared, or the acceleration can be referred to as minus 80. In the second part, we've got a change in speed of 50. So A here is minus 50 because we've gone from 50 down to 0. Divided by half an hour, so that would be 0.5. So that's going to be minus 100 miles per hour squared. So there we are, that's the answer to what the deceleration is here. Okay, so your turn to have a go at a couple of questions then. Find the acceleration and deceleration of the two sections on this graph. Pause the video and have a go at that one. Okay, so we'll call it section A, section B and section C. Section A first then. We have a difference in y, so the acceleration will be 7 over the course of 3 seconds. So that would be 2.33 meters per second squared. And then in section C, there's going to be no acceleration in section B because it stays at 7 meters per second. The acceleration at C will be going from 7 down to 3, so that would be minus 4 over 6 to 12, so that would be over 6 seconds, so that would be 0.67 meters per second squared. So that's the answer to question 1. Hopefully that's made sense and hopefully you've got that one right. If you haven't, an opportunity to have another go at a question here. Pause the video and work out the acceleration and deceleration here. Okay, we'll refer to them as section A, section B and section C again. For section A, we have some obvious deceleration. So the deceleration is going from 5 down to 2, so that is taking away the speed of 3. That's over the 5 seconds that's happened, so that would be minus 0.6 meters per second squared, or you could say the deceleration is 0.6 meters per second squared. For section C, we have a speed going from 2 up to 9, so that's an increase of 7 divided by 5 seconds. So 7 divided by 5, let's just grab a calculator. 7 divided by 5 is 1.4, I think. Yep, 1.4. 1.4 meters per second squared. And that's positive because it's accelerating, it's increasing its speed. One final question on this little topic here. Pause the video and give this question a go. Make sure you get the units correct. Okay, so let's refer to it again as section A, section B and section C. So for section A, we have an increase in speed of 50 divided by the time that was taken. That was half an hour, so 0.5 hours there. So the acceleration is going to be 100 miles per hour squared. And moving on to section C, the increase in speed is from 50 to 100. So 50, and that's over the course of 2 3/4 of an hour. So 1 3/4 of an hour. So 1.75. So in this case, grab a calculator. So 50 divided by 1.75. And that equals 28.6 to 3 significant figures. 28.6 miles per hour squared. And there we are, that's the answer to both of these questions. Okay, so we can calculate acceleration and deceleration, but there's also something you can do that's different with velocity time graphs, and that is actually you can work out how far you've travelled using this graph as well. And the way you can do that is by calculating the area underneath this curve. So what you've got to do is you've got to divide it up into separate sections and then work out the dimensions of the shape using the axes on the side. So the first one's going to be a rectangle. The second area, well, that's going to be a little bit more difficult to work out. The third area, that will be a rectangle, and the fourth area, that will be a triangle. So the first area, we'll divide it up into sections A, B, C and D maybe. And section A is a rectangle, so that's going to be base times height. The base there is 1 and the height is 70 using dimensions on the side. So in section A, the person has travelled 70 miles on the motorway. Now, as I say, section B, that's going to be the more difficult one to work out. What kind of shape is this in this section B here? Well, if we remove everything away, it's very similar to a trapezium. A trapezium looks like this generally, but this is a trapezium kind of on its side. And there's no reason why one of the sides on the trapezium can't have a right angle on it. And the way we work out the area of a trapezium is we do the two parallel lengths, add them together, divide it by 2 to find an average width, and then times it by the height. In this case, it's going to be on its side. So this side here is going to be A, this side here is going to be B, and the height is actually the width of the shape. And the formula is A plus B divided by 2 times by H. What we're effectively working out in this bit of the formula is the average height of the bar, or the average speed that someone would be travelling at in our case. Then it'd be add them together, divide by 2, and then it'd be times by height. In this case, it would be times by the time. So go back to the question then. We'll remember this formula in the corner of our brains, and we'll work out this area. It's going to be one height on the left-hand side of 70, one height on the right-hand side of 50, divided by 2, and that will effectively calculate the average speed for this quarter of an hour. The average speed in this quarter of an hour will be 60. 70 plus 50 is 120 divided by 2, that's 60. So it's going to be 60 times by the height, or in this case the height will be the width of the bar. And that's 0.25 hours, 15 minutes, a quarter of an hour. So it's going to be 60 times 0.25 is 15 miles. So in this area here, we use the area of a trapezium formula to work out that would be 15 miles. For the third section, it's going to be base times height. So that's going to be 50 times by 0.75, 3/4 of an hour. That's 37.5. And in section D, that's a triangle. So that's base times height divided by 2. The base here is 0.5, half an hour, times by the height of 50, divided by 2. That's 12.5. And the total distance will then be all of these individual distances added together. So that's 135 miles that car will have travelled throughout that whole journey. Alright then, so your turn to have a go at this question here then. So your turn to work out the distance travelled, divide it up into 3 sections. One's a triangle, one's a rectangle, one's a trapezium. Work out all the different areas, add it together, and you've got your total distance. Pause the video and give this question a go. Okay, so in this question here we have the first section, that's in trapeze, so that's a triangle area. In the second section we have a rectangle, and in the third section we have a trapezium. So the first section, we'll call it section A, is going to be base times height divided by 2. The height of this shape is 7, the base of this shape is 3, and divide that by 2, that would be 21 divided by 2, so 10.5, and the units on this is meters. For section B, that's just going to be base times height. The base here has a width of 3 and a height of 7. So 3 times 7 is 21 meters. For section C, a little bit more difficult. It's a trapezium. If you turn your head on the side, you'll see that we've got a trapezium. We've got the 2 parallel sides, is this one here and this one here. So on the formula, this side is going to be A and this side is going to be B. So the height of this side is 7, plus the height of this side is 3, and we'll divide that by 2. Well, that's effectively worked out is that during this distance, during this time from 6 to 12 seconds, the average speed was 5. So the average height of this shape here is 5. It's a little bit taller on this side, a little bit smaller on this side, but the average height was 5, or the average speed was 5 meters per second. Then multiply that by the time taken, or in this case the height or the width of the bar, so that's going to be 6. So that's going to be 5 times 6 is 30 meters. The total distance travelled therefore is going to be 10.5 add 21 add 30, so that's going to be 30, 50, 60, 1.5 meters travelled. So there we are. Let's give you another chance to have a go at a question like that. Pause the video and work out the distance travelled in this graph. Okay, so let's divide it up into 3 separate shapes. It's not always 3 shapes, it might be more shapes than that, or it might be less shapes than that. So we've got section A, section B, and section C. For section A, it's a trapezium, so it's going to be 5 plus 2, that's the height on this side, and then the height on this side. Divide that by 2, and then times by the width of the bar, which is 5. So that's going to be 7 divided by 2 is 3.5, and 3.5 times 5 gives us 17.5 meters. In section B, that's a rectangle, or a square actually. It's going to be 2 times 2, that's 4. In section C, it's going to have a height on this side of 2, a height on this side of 9. So that's going to be 9 plus 2 divided by 2, times by the width of the bar, which is 5 seconds. So 9 plus 2 divided by 2, and then times that by 5, that gives us 27.5. So the total distance travelled will be these 3 sections added together, 17.5, add 27.5, add 4, which gives us 49 metres travelled in total. And one more to have a go at, just to make sure you've got this absolutely sussed before we go on to the worksheet. Pause the video and give this question a go. Okay, so in this shape of the graph here, we have a triangle, a rectangle, and a trapezium. And remember, this is miles per hour and hours. So in this case here, it's going to be a base, so section A, it's going to have a base of 0.5 times by a height of 50 divided by 2, because it's a triangle, that's the formula for the area of a triangle, base times height divided by 2, so that's going to be 12.5. And that's going to be 12.5 miles. In section B, we have a rectangle, and that's just going to be 3/4 of an hour, 0.75, multiplied by the height of 50, so 0.75 times 50, 0.75 times 50 equals 37.5 miles. And in section C, it's going to be a trapezium, so our two heights will be 50 and 100, and that's calculating that on average our speed during this time would be 75 miles per hour. Times by the width, so the height of this bar really, that would be 1.75. We're travelling that distance, so travelling at that speed for 1.75 hours. 1 hour and 3/4. So 75 times 1.75, and that is 131.25 miles. So when we find the total, it's going to be 12.5, add 37.5, add 131.25 equals, so let's add the 3 results together, add 12.5, add 37.5 equals 181.25 miles. Just before I move on from this question, I don't condone travelling at 100 miles per hour. Maybe they were doing it on a very safe road where they could do that kind of speed, but don't do it at home. Okay, so to summarise the velocity time graphs video, we have on velocity time graphs, the gradient is the acceleration, and to work out the acceleration you do the change in velocity divided by the change in time. And also you can find the area that you've travelled by working out the distance, so the distance you've travelled as the area underneath the curve. When you're doing this, effectively what you're doing is a calculation of distance equals velocity times time, or speed times time. So it all links back into distance equals speed times time. Right then, what I'd like you to have a go, and the area of trapezium formula is a very helpful formula to know in this particular question. So what I'd like you to do now is have a go at the questions in the description of the video. There's quite a few, so have a look at the questions. Do them either as we go along, so do one question at a time, checking the answers as you go, or just do the full worksheet. Let's have a look at the first one then. Pause the video and give this question a go. Okay, so let's have a go at the first question then. So what was the velocity of the particle when time equals 9? Well, time equals 9 would be at this point here, so that would be at this point here on the graph. So I reckon it would be about 28 meters per second. So that's just a question of reading the graph. How long did the particle travel at constant speed? Well, it travelled at constant speed for this part of the graph here, where the graph is flat, so that's 5 seconds. Find the acceleration when t equals 9 and when t equals 23. Well, let's do the first part. Let's do 9 seconds. So that's during this section of the graph from here to here. So we'll work out the gradient of the graph during this section here. The gradient is going to be a calculation of difference in velocity, which is 10, divided by the time taken, which is 5. So that's going to be 2 meters per second squared. When time is 23, that's in this section of the graph from here to here, so we'll work out the deceleration of the graph here. That's going to be a change in the speed of minus 10 divided by 10 seconds. So this is going to be minus 1 meter per second squared. So that's obvious that that part of the graph is decelerating and this part of the graph is accelerating. The speed is getting bigger here by 2 meters per second every second, and the speed is decreasing here by 1 meter per second every second. Part D is what was the initial acceleration? Well, the initial acceleration would be during this section of the graph from here to here, the initial part of the graph. So that's going to be an increase in speed of 20 over 5 seconds, so that's going to be 4 meters per second squared. Let's move on to the next part of this question, part E, F and G. So what was the initial velocity? The initial velocity was 0 meters per second. Find the total distance travelled. Well, let's then divide all of the regions up into, all the graph into different regions, A, B, C, D and E. So region A is going to be a triangle. That's going to be base times height divided by 2. 20 times 5 divided by 2, that's 50 meters. Section B, that's a trapezium. So that's going to be 20 plus 30 divided by 2 times by this time of 5. So that's going to be 25 times 5, that's 125 meters. Section C, that's a rectangle, so that's going to be base times height. 5 times 30 is 150 meters. Section D is going to be another trapezium, so that's going to be 20 plus 30 divided by 2 times by 10 seconds, this one. So that's going to be 50. Let's be 50 times by 10, so that's going to be 500 meters. Sorry, no, 250, sorry, so we divide by 2, don't we? 250 meters. And then this final section here is a triangle, so that's going to be base times height divided by 2, 20 times 5 divided by 2, and that's going to give me 50 meters as well. So the total distance travelled is going to be 50, add 125, add 150, add 250, add 50, and that gives us a total distance travelled of 625. Part G, find the average speed for the whole journey. Well, remember the average speed from the distance time graphs video, average speed, the formula for it is total distance divided by total time. Let's just write that all out. Total distance divided by total time. This was included in the distance time graph video. So the distance travelled was 625 divided by 30 seconds. 625 divided by 30 gives us 20.83 recurring. and that's going to be meters per second. Lovely, there we are. So that's the answer to question 1. Let's move on to question 2. Pause the video and give this question a go. Okay, so part A, what was the velocity when the particle was at t=9? At 9 seconds, the speed was 10 meters per second. What was the greatest acceleration? Would probably be in this section from here to here. So 20 up to 50 would be 30, divided by 5 seconds, so that would be 6 meters per second. What was the least acceleration? Well, the least acceleration would either be 0, but actually it could be the negative part here, from 50 down to 0, so that would be taking away 50, over the course of 5 seconds, so that would be minus 10 meters per second squared. What was the greatest speed? The greatest speed was the greatest velocity, so that's 50 meters per second. Moving on to part E, F and G, what was the initial velocity and acceleration? The initial velocity was 10, v = 10 meters per second, and the initial acceleration was 0 meters per second squared. So notice the difference in the notation, difference in the units. It's meters per second for velocity, but it's meters per second squared for acceleration. Find the total distance travelled. Well, let's divide the graph into separate regions. 1, 2, 3, 4, 5. So 5 regions. We'll call first part region A, and that's a rectangle, so that would be base times height divided by 2. So base times height, that's 100 meters. In section B, that's a trapezium, so it's going to be 10 plus 20, divide that by 2, multiplied by the time of 5, so that's going to be 15 times 5, that's 75 meters. Part C is going to be another trapezium, that's going to be 20 plus 50, divide that by 2 times by 5 seconds, so that's going to be 35 times 5, which is 175. Section D is a rectangle, that's just going to be base times height, 5 times 50 is 250. And section E is a triangle, base times height divided by 2, 5 times 50 divided by 2 is 125 meters. The total distance travelled will be all of these distances added together. So 100 add 75, add 175, add 250, add 125 equals 725 meters. And then the average speed will be total distance travelled divided by total time, that's 30 seconds. So 725 divided by 30 equals 24.2 meters per second. Okay, so that's the answer to question 2. Let's move on to question 3 now. Pause the video and have a go at question 3. Okay, so what's the velocity for the particle and t = 10? That's going to be 30 meters per second. That's just a case of reading the graph. What was the acceleration when t = 24? Well, when t = 24, we're in this section of the graph from here to here. There's a very small deceleration going from 30 to 28, so that would be minus 2 meters per second. That's happening over the course of 5 seconds, so that's going to be minus 0.4 meters per second squared. What was the least acceleration? So the least acceleration will be this gradient here, from 28 down to 0 over the course of 5 seconds. So minus 28 divided by 5. 28 divided by 5 is 5.6, so minus 5.6 meters per second squared. What was the greatest speed? The greatest speed was right at the start, 40 meters per second. Let's move on to questions E, F and G. What was the initial velocity and initial acceleration? So the initial velocity was 40 and the initial acceleration was this part of the acceleration line here. So that was going down by 10 meters per second over the course of 10 seconds, so minus 1 meters per second squared. The total distance travelled, let's divide the graph up into 4 separate sections here. Section A was a trapezium, so that would be 40 plus 30 divided by 2 times by 10, so that's going to be 70, 35, 350 meters. Part B is a rectangle, that would be base times height. 30 times 10 is 300. Section C is a trapezium, that's going to be 30 plus 28 divided by 2 times by 5. So that's going to be 29 times 5, which is 145. And section D is a triangle, that's going to be 28 times 5 divided by 2. 28 times 5 divided by 2 equals 70 meters travelled there. So the total distance travelled here is going to be 650 add 145 add 70 equals 865 meters. And then the average speed will be distance divided by time. 865 divided by 30 seconds. So divide by 30 and that equals 28.8 meters per second. Right, that's the answer to question 3. Let's move on to question 4 now. So pause the video and give this one a go. Okay, so a car accelerates uniformly from a velocity of 10 meters per second to a velocity of 40 meters per second over the course of 10 seconds. So on your graph, you'll need some time going along the bottom, up to 10 seconds, and then you'll need to make sure you can go up to 40 meters per second on the y-axis, 10, 20, 30, 40. Let's make sure we put the units on. This is going to be in time of seconds, and this is going to be velocity in meters per second. So we're told here that the velocity goes from 10 up to 40 over 10 seconds. So get a ruler and then connect those two curves together, connect those 2 points together. So that's the graph then. Sketch the velocity time graph and find the acceleration and the distance covered by the car over the 10 seconds. So acceleration here is going to be an increase of 30 meters per second over 10 seconds. So that's going to be 3 meters per second squared. So that's the acceleration. Let's now do the area or the distance travelled. And that's a trapezium. It's going to be from 10 to 40, so 10 plus 40 divided by 2, times by the time taken, which is 10 seconds. So that's going to be 50, 25, 250 meters travelled. And there we are, that's the answer to question 4. Let's move on to question 5. Pause the video and give this one a go. Okay, so let's have a go at question 5 then. So a particle is moving in a straight line from rest. So if it's from rest, that means it starts from 0. So we can start our graph at 0, 0. At uniform acceleration, what it means by uniform is just constant. So we don't really need to know what that word means. It's always going to be constant acceleration. So don't worry too much about that word. 4 meters per second squared for 4 seconds. So if we go up by 2's maybe, 2, 4, 6, 8, 10, 12, 14, 16. So it's going to, and then 1, 2, 3, 4. It's going to go up by 4 meters per second every second. So 4, 8, 12, 16. So that's what's happened to this car. It's increased its speed by 4 meters per second every second for 4 seconds. So that's what's happened to the car. It is then brought to rest again by a uniform acceleration of -2 meters per second. So now every time I move right by 1 second, I need to go down by 2. So it's going to be down by 2, down by 2, down. Will I run out of space? No, thank goodness. So 6, 7, 8, 9, 10, 11, 12. So it takes up to 12 seconds for that to decrease in speed at a rate of 2 meters per second every second. So it's decreased in speed by 2 meters per second every second that's travelled on. So this is a velocity time graph. Let's put the axes in. And the final question we've got here is find the total distance travelled. So what we'll do is we'll divide the sections of the graph into 2. So we'll have base times height divided by 2, 4 times 16 divided by 2. That would be 32 meters for section A. And then section B is another triangle, so that would be 4 up to 12, that's 8 times by 16 divided by 2. So that's going to be pretty much double what we've got already, 64 meters. So the total distance travelled there, 32 plus 64, is 96 meters. So that's the answer to the total distance covered by the particle. Let's move on to question 6. Pause the video and give this one a go. Okay, so in this question we have a particle moving from rest to in a straight line. So in a straight line with an acceleration of 4 meters per second for 3 seconds. So let's do it again. Let's do 2, 4, 6, 8, 10, 12, 14, 16. Let's see if we need to go any further. So it's 4 meters per second every second for 3 seconds. So 1, 2, 3. That's got it up to 12 meters per second. So it's going up by 1 second each time here. It maintains a uniform velocity for 6 seconds. So it's at 3 at the moment. So it will go up to 9. And it is brought to rest again. Oh, I'm going to have to go to 13 here. Whoops. In a time of 4 seconds with uniform deceleration. So it's from 9 up to 13. So there it is. It's going to go up to 13 seconds, uniformly decelerating. And that means just at a constant rate. Sketch a velocity time graph and find the final acceleration and the final displacement of the particle from its starting point. Displacements are basically a posh word for distance. So find the final acceleration, so that's from this point here to this point here. We've had to decrease our speed by 12, so that's minus 12 divided by 4. That's going to be minus 3 meters per second squared. And the final distance travelled, well, this is also a trapezium. If you look at it from a different perspective, this is going to be A, this is going to be B, and then the height of the graph is actually going to be H in this instance. So it's going to be height, so A here is going to be 6, this is distance, equals 6 add 13 divided by 2 times by the height of this graph is 12. So let's do it on the calculator. 6 plus 13, divide that by 2, but then times by 12. That's 114 meters travelled. Alright then, and that's all we're going to go through in this video then. So we've done the 6 questions from the worksheet. Thanks very much for watching the video, and hopefully you'll keep an eye out for some curvy distance time graphs or some curvy velocity time graphs. Thanks very much for watching.